Hello dear students, let's see an example of NPDA, non-deterministic pushdown automata. Now imagine that we are asked to develop a PDA for language W raised to R, that is W reverse, where W is element of 0, 1. Just check the language. Let's put closure over here. These are the words that should be in the language, where this word W itself is made up of any combination of 0 and 1, and this W raised to R is just the reverse of the word. So if we think of the language, let's say we take this W, the first word, as 0, correct? Because we can take anything from 0 and 1. So the next component W raised to R will be reverse of this, which is 0. This will be one word. Let's say we take this W, the very first component, as 1. So from this 0, 1 we have taken 1. Then W raised to R will be reverse of this word, that is 1. Let's go ahead. Suppose this W, the first component, I take as 0, 1. As you know, this W can be made up of any combination of 0 and 1. But then the second component, W raised to R, should be reverse of 0, 1, which is 1, 0. So you will agree that 1, 0, which if we take W as 1, 0, then W reverse will be 0, 1. Or let's say we take 0, 0 as W, then reverse will be 0, 0. So this is W raised to R. Or if we take W as 1, 1, then W reverse will be 1, 1. Or if we take W as 0, 0, 0, then reverse will be 0, 0, 0. Or 0, 0, 1, then reverse will be 1, 0, 0. Just observe, all such strings will be there in the language, where individual word, if you see individual string, is made up of W followed by reverse of W. I repeat, individual word is made up of W followed by reverse of W. Check that all these strings, all the strings of language L, sorry for this handwriting, just this is language L, are even length palindromes. Even length palindromes. Just see, all the strings are even length. Maybe we have got palindrome of length 2, or palindrome of length 4, or palindrome of length 6. So next will be palindrome of length 8, then 10, and so on. We will never get a palindrome of length 5. There is also one more string which is accepted by this language, is epsilon. Because when we say that W is made up of closure 0, 1 closure, then empty string is also included. What that means is the word W can be empty, then the reverse of this word is nothing but empty. So that's epsilon followed by epsilon, which is epsilon. And you will agree that an empty string is palindrome of length 0, and according to us 0 is even. I know 0 is neither even nor odd, but we accept it without loss of generality that 0 is even. Then even this is the palindrome of length even length. All the strings are palindromes of even length. This PDA can be developed only by using non-deterministic pushdown automata. Look, this problem cannot be solved using DPDA. You will know why in short time. But recall, just 1 or 2 videos back, we developed this language, W raised to R, where W is made up of 0, 1 closure. Recall this? And the strings in this, where C was the smallest string, then 0C0, 1C1, 0, 1C1, 0, and so on. All strings were odd length palindromes. Odd length palindromes. And this was developed by using DPDA. We were not forced to use NPDA, isn't it? We constructed DPDA for this. Now why? Let's reason out this. Why DPDA was possible? The point is that there was a constant character C perfectly in the center. Perfectly in the center. And if you want to prove that this string is a palindrome, then what you have to do is that after crossing the center, when you cross the center, you know that you are in the second part of the string. And then the second part of the string, if it begins with 1, you can match it. You can match it with the character which is stored previous to the C. But then important thing is, you know, or PDA can determine when to check the match, between the symbols, or when to match the symbols. It will start matching only after crossing the center. So before crossing the center, let me take a fresh example. Suppose we have a palindrome like this, 0 1 1 0, let's say, and then center. Surely this is 0 1 1 0. So you recall stack initially stores Z0. Now as PDA proceeds in the string, it will keep pushing X for 0, Y for 1, Y again for 1, X for 0. I hope you recall this example. And then when it encounters center, it takes no action. It only registers that it has found a center. And now when it reaches this 0 after the center, it knows now it has to match this 0 with 0. So it will pop the topmost X. And then when it reaches this one, it knows it has to match this one with 1. So it will pop Y. Again for this one, it will pop this Y. And for this 0, it will pop X. And then when we reach end of the string, we have only Z0 left on the stack. So we'll say this string is accepted and we will reach final state. But the point is that this center guided PDA when to start checking. But here in this example, in this language, we don't have any center. So if given an arbitrary input to our PDA, just see, if this is W, 0 1 0 1 1 0, then reverse will be 0 1 1 0 1 0. This is a palindrome. Look, this is the center. This is the center. So after reaching this point, our PDA should start matching. That whether the second component is reverse of the first component. But the problem is, how would PDA come to know that it has reached the center? There is no constant character like C. Because there was a constant character C, PDA could determine when to start matching the characters of the right hand side or the second part with the first part. Here we don't have any such center. Then it cannot be developed, this machine cannot be developed using DPDA. We will have to use non-determinism. And the idea will be seen in the next video. What will be the machine developed for these even length palindromes without any constant character C separating the two parts, W and W reverse. There is no separating character. Okay, so see you in the next video. Thank you very much.